Welcome to Colonize the Ocean podcast, where we discuss oceanic colonization, exploration, and education with your hosts Adam Jewell and Brendan Traxler.
Welcome to the Deep Dive. We're going deep underwater today.
Oh, yeah.
Yeah. To explore the fascinating world of underwater habitats.
Cool.
You know, those structures that allow people to live and work beneath the waves.
Right.
Well, we've got a great article here all about a company called Deep,
Okay.
which is doing some seriously cool things in this field.
Interesting.
And get this. It all started with a bunch of dreamers and daredevils
Yeah.
way back in the 1960s.
Wow. So
So-
what's so intriguing about this topic is
Yeah.
how the dream of living underwater has persisted for decades.
It's so cool.
You know, it's incredible to see how technology is finally catching up to that ambition.
I know, right?
Yeah.
It's like something that's science fiction.
It is, yeah.
But it all started with some pretty basic, even homemade attempts. This article tells the story of two young guys in England,
Okay.
Colin Irwin and John Heath,
Okay.
who built an underwater habitat called Glaucus in the 1960s.
Okay.
Now, they weren't the first to try this,
Right.
but their DIY approach really stands out.
Yeah, it's remarkable what they achieved with limited resources.
I know.
They even managed to create a self-sufficient air supply system.
That's crazy.
A pretty big deal back then. And it's something that directly connects to Depp's work today,
Wow.
with their focus on autonomous habitats.
So how did we get from those early DIY efforts to the sophisticated habitats Deep is building today? It seems like a huge leap.
Well, there were a lot of important steps along the way.
Okay.
One of the most influential figures in this field was Jacques Cousteau.
Oh, yeah.
You've probably heard of him.
Of course.
The guy with the red beanie.
Oh, absolutely. He's like the poster child for ocean exploration.
Exactly. And he wasn't just an explorer.
Right
He
now.
was a visionary who dreamed of humans living underwater for extended periods.
For sure.
His Conshelf missions in the 1960s were groundbreaking.
Yeah, this article mentioned Conshelf too,
Right.
and how they had gourmet meals and even a pet parrot living down there. It sounds more like a luxury apartment than a research station.
Cousteau understood that for humans to thrive underwater,
Yeah.
they needed more than just the bare necessities.
Right.
Creating a comfortable and even enjoyable living environment was crucial,
For sure.
especially for longer missions.
Right.
And, you know, Deep is taking that same approach today,
Okay.
prioritizing the well-being of the crews and their habitat.
That makes sense.
Yeah,
Happy scientists,
Yeah.
better research. Right.
exactly.
Okay, but back to Conshelf. What exactly did they achieve?
Well, Conshelf actually involved 3 separate missions,
Okay.
each building on the last.
Hmm.
Conshelf 1 proved that humans could live underwater
Wow.
for an extended period.
Okay.
Conshelf 2 pushed the boundaries further
Ugh.
from a month-long stay in a larger,
Wow.
more comfortable habitat.
That's cool.
It was actually a network of underwater structures
Oh, wow.
at different depths.
So they were getting pretty ambitious.
Yeah.
What about Conshelf 3?
That one focused on going deeper.
Okay.
They reached a depth of 100 meters.
Wow.
Reaching those kinds of depths is a major goal for Deep as well.
Okay.
Remember, the deeper you go,
Yeah.
the more challenging the environment becomes.
Makes sense.
Yeah.
While Cousteau was making waves literally in the Mediterranean and Red Seas,
Mhm.
there was another group pushing the boundaries of underwater living,
Okay.
the U.S. Navy.
Oh, interesting.
Yeah. The Navy had its own program called Sealab,
Okay.
led by a physician named George Bond, often called Papa Topside.
What a name!
I know.
Papa Topside.
His research on saturation diving completely revolutionized underwater exploration.
Interesting.
Okay, I've heard of saturation diving,
Yeah.
but I'm not entirely sure I understand how it works.
Imagine soaking a sponge in water.
Okay.
Eventually, it becomes completely saturated.
Right.
It can't absorb any more water.
Yeah.
Our bodies do something similar with gases when we're underwater. Bond figured out that if you let a diver's body become fully saturated with gases at a certain depth, they could theoretically stay there indefinitely without needing to decompress later.
So no more coming up slowly to avoid the bends.
Exactly.
That's a game changer. No wonder they called him Papa Topside. But how did that translate into actual underwater habitats?
Sealab was the answer to that.
Okay.
They built 3 different Sealab habitats, each progressively more advanced.
Okay.
Sealab First, launched in 1964, was America's first true underwater habitat, going down to 60 meters.
Wow, even deeper than the initial Conshelf missions.
Exactly.
Oh.
But it had a rough start.
Oh, no.
A storm forced them to cut the mission short after just 11 days. Still, it proved the concept was viable.
So what happened with Sealab the second and third?
Sealab Sentin launched the following year, went even deeper, 62 meters.
Wow.
And this time they stayed down for weeks, proving the practicality of extended stays.
So it was like a real race to conquer what they called inner space. Kind of like the space race.
Yeah.
But underwater.
Exactly.
Okay, cool.
And just like the space race, there were setbacks and risks.
Right.
Sealab III, launched in 1969, was an ambitious attempt to go even deeper, down to 180 meters.
Wow.
But they encountered some serious technical problems, highlighting the inherent dangers of pushing the boundaries of underwater exploration.
Yeah, that makes sense.
Yeah.
Those early pioneers really paved the way for what deep is doing today.
Right.
It's amazing to think about all the challenges they faced and overcame. But what about those 2 guys who built Glaucus?
Yeah.
How does their DIY habitat fit into the bigger picture?
Their focus on self-sufficiency was truly ahead of its time.
Yeah.
Remember, they created their own air supply system?
Right.
It was a small-scale experiment, but it foreshadowed the autonomous systems that Deep is now perfecting.
So it's not just about going deeper or staying longer.
Right.
It's also about creating habitats that can function independently, right?
Absolutely.
Okay.
And that autonomy opens up a whole new world of possibilities for underwater exploration and research.
That's where those big underwater habitats come into play, right? The ones that look like they belong in a sci-fi movie.
Exactly. The ones Deep is building today.
Okay.
But to understand how we got here,
Yeah.
we need to look at some of the other habitats that came after Sealab.
Okay, let's do that. What happened in the world of underwater habitats after the 1960s?
Well, there were a few key projects that bridged the gap between those early efforts and what Deep is doing today.
Okay.
One was called La Chalupa, launched in 1972.
Okay.
It was unique because of its barge-like design, which made it easy to transport to different locations.
Sounds familiar.
Yeah.
Deep also emphasizes the portability of their habitats, right?
You got it.
Okay.
They learned from those earlier designs. Making habitats easy to deploy is crucial for maximizing their research potential.
Yeah, for sure.
Imagine being able to quickly relocate a habitat to study a newly discovered coral reef or a unique deep-sea ecosystem.
That's fascinating.
Yeah.
So La Chalupa was all about marine biology research.
Yeah.
What other types of habitats were developed during this time?
There was another one called Aquarius Reef Base. It was established in 1986 and served as a long-term underwater laboratory for over 3 decades.
Wow, a whole underwater lab.
Yeah.
What kind of research did they do there?
Scientists from all over the world used it to conduct a wide range of marine research. They studied coral reefs, fish populations, and even the effects of pollution on the ocean environment.
Wow.
And get this.
Yeah.
NASA even used Aquarius for astronaut training.
Wait, astronauts training underwater?
Yeah.
That's incredible. What's the connection?
Well, the challenges of living and working in an extreme environment like the ocean floor are surprisingly similar to those faced by astronauts in space.
Yeah.
It's all about adapting to limited resources, isolation, and the psychological pressures of living in a confined, dangerous environment.
Okay, that makes sense.
Yeah.
It's amazing how these different fields of exploration can learn from each other.
Yeah, for sure.
But where does Deep fit into all of this?
Well, Deep is building on the legacies of all these pioneers, taking the best of what they learned and incorporating cutting-edge technology to create the next generation of underwater habitats.
This is all so cool. I can't wait to hear more about what Deep is doing and what the future holds for underwater living.
Me too. And that's exactly what we'll be exploring in the next part of our deep dive.
So stay tuned. We're back and ready to dive even deeper into the world of Deep and their incredible underwater habitats. They're really pushing the boundaries of what's possible. But before we get into the specific, I'm curious, why is Deep so focused on building these elaborate self-sufficient habitats.
Right.
Couldn't they just use existing technology, like submarines or ROVs for ocean research?
That's a great question.
Yeah.
And it gets to the heart of what makes Deep's approach so innovative.
Okay.
Submarines and ROVs are fantastic tools for exploration, but they have limitations.
Okay.
They can only stay underwater for a certain amount of time.
Right.
And they require constant support from the surface.
Makes sense.
Deep's habitats, on the other hand, are designed for long-term stays with minimal reliance on surface support.
So they're like underwater research stations.
Precisely.
Yeah.
Allowing scientists to live and work in the ocean environment for weeks or even months at a time.
That's cool.
Yeah.
Okay, that makes sense. But let's talk about the technology involved.
All right.
How do they make these habitats self-sufficient?
Right.
We touched on those two guys in England and their DIY air supply system. But Deep's habitats are on a whole other level, right?
Absolutely. Deep has taken the concept of self-sufficiency and applied cutting-edge technology to create truly autonomous systems. For example, their life support systems are designed to operate independently for extended periods.
That's pretty wild.
They have advanced air filtration systems that scrub carbon dioxide from the air and replenish oxygen levels. So just like the systems on the International Space Station.
Wow. So they're basically creating a mini Earth down there.
Pretty much.
What about waste management?
Oh, yeah, good question.
You can't just dump sewage into the ocean, right?
Definitely not. Protecting the marine environment is a top priority.
Okay.
That's why Deep's habitats have sophisticated waste management systems that treat and process wastewater, preventing any harmful contaminants from entering the ocean.
That's impressive. It sounds like they've thought of everything.
Yeah.
But what about power? All those systems must require a ton of energy.
You're absolutely right.
Yeah.
Powering these habitats is a major challenge.
All right.
But Deep is utilizing some creative solutions.
Okay.
They're incorporating renewable energy sources whenever possible, like solar panels for surface structures and even underwater turbines that harness the power of ocean currents.
It's like having a little off-grid underwater city.
Kind of, yeah.
So they've got the life support systems, the waste management, the power figured out.
Right.
But what about the habitats themselves? What's it like to live inside one of these structures?
Well, imagine this.
Okay.
You enter through a pressurized airlock, leaving the watery world behind.
Okay.
You step into a spacious common area, bathed in warm, inviting lighting.
Sounds nice.
There's a comfortable seating area, maybe a large screen for watching movies or video conferencing with colleagues back on land. There might even be a gym or recreational area for exercise and relaxation.
Okay, now it's starting to sound less like a research station and more like a luxury hotel.
Yeah.
But surely there are labs and workspaces as well.
Of course. Adjacent to the living areas are state-of-the-art research labs equipped with everything scientists need to conduct their experiments and analyze their findings.
Cool.
There are microscopes, computers, specialized equipment for collecting and processing samples, and even robotic arms for manipulating objects in the surrounding environment.
It sounds incredible.
Yeah.
So they've managed to combine the practicality of a research facility with the comfort and amenities of a, well, I hesitate to say it, but almost like a resort.
It's about creating an environment where scientists can not only survive, but thrive.
For sure.
Remember what we discussed about Cousteau and the importance of psychological well-being?
Right.
Deep takes that very seriously. They want to ensure that researchers can focus on their work without feeling isolated or deprived.
That makes sense. And it probably leads to better research overall.
For sure.
But let's talk about the specifics of what Deep is doing.
Okay.
What kind of habitats are they building?
Right.
And how do they differ from those earlier habitats we discussed?
Well, Deep is currently developing several different types of habitats, each designed for specific purposes.
Okay.
They have the Sentinel, which is designed for long-term stays at depths of up to 28 days.
Oh, wow.
Kind of like Conshelf 2, but with 21st century technology.
So what makes the Sentinel so special? What kind of technology are we talking about?
The Sentinel incorporates some truly groundbreaking advancements. For example, it has an advanced air revitalization system that uses algae to scrub carbon dioxide from the air and generate oxygen through photosynthesis.
So they're like...
It's like having a mini rainforest inside the habitat, constantly purifying the air.
Wow. So they're mimicking natural processes to create a self-sustaining environment.
Exactly. And that's just one example.
Wow.
The Sentinel also has advanced waste management systems that use bioreactors to break down organic waste and convert it into fertilizer, which can then be used to grow food in the habitat's hydroponic gardens.
Wait, they're growing food underwater?
Yes. They're experimenting with hydroponics and aquaponics.
Wow.
Growing plants in water and using fish waste as fertilizer to create a closed-loop food production system.
It's incredible. They're really pushing the boundaries of what's possible.
Yeah.
But what about other types of habitats? Is the Sentinel the only one Deep is developing?
Not at all. They also have the Sentinel, which is designed for deeper deployments, going down to 200 meters. 200
meters.
Yeah.
That's deeper than any of those early habitats we talked about.
Yeah.
What kind of challenges do they face at those depths?
Well, the pressure at that depth is immense.
Yeah.
Over 20 times the pressure at sea level. So the habitat has to be incredibly strong and durable to withstand those forces.
Right.
They also have to deal with the extreme cold and darkness at those depths.
Yeah, that makes sense.
Yeah.
Sounds like building these habitats is a real engineering feat.
It absolutely is.
Yeah.
It requires expertise in materials, science, robotics, life support systems, and a whole host of other disciplines.
Wow.
It's really cutting-edge stuff.
It's mind-blowing to think about all the innovation going on in this field. So they've got the Sentinel for long-term stays and the Sentinel for deeper deployments.
Right.
What other types of habitats are they working on?
Well, one particularly exciting project is the Outpost, which is designed to be a mobile habitat. It's essentially a large submersible platform that can be transported to different locations and then submerged to provide a temporary underwater base camp for researchers.
So it's like a portable underwater laboratory.
Exactly. It could be used to study a wide range of environments, from coral reefs to deep-sea trenches. It gives scientists incredible flexibility to conduct research in remote and challenging locations.
It sounds like Deep is really covering all the bases. But I'm curious, what about the human element?
Right.
We've talked about the technology and the research. But what's it like for the people who actually live and work in these habitats?
That's a fascinating question. And it's something that Deep is paying close attention to. They're working with psychologists and human factors experts to ensure the mental and emotional well-being of their crews.
I imagine living underwater for weeks or months at a time can be pretty isolating and challenging.
You're right. Even with all the comforts and amenities they're building into these habitats. That's why they're designing habitats with ample space for privacy and relaxation, incorporating natural light whenever possible, and providing access to virtual reality experiences to simulate the outside world.
Virtual reality underwater? What's that like?
Imagine putting on a VR headset. And suddenly finding yourself walking through a forest or strolling along a beach, even though you're hundreds of feet below the surface. It's a way to combat the feeling of isolation and maintain a connection to the world above.
That's pretty cool. It sounds like they're really trying to create a holistic living experience. Considering both the physical and psychological needs of the crew.
Exactly. They're approaching it from a very human-centric perspective. They understand that to be successful in this field, they need to create environments where people can not only survive, but thrive.
This has been so enlightening. I feel like I'm starting to grasp the complexity and the incredible potential of these underwater habitats. But I have one more question. What about the future? Where does Deep go from here? What's next on the horizon?
That's a great question to end on, and it's something we'll explore in the final part of our deep dive. Stay tuned. We'll be right back.
We're back for the final part of our deep dive into the world of underwater habitats. And I'm so excited to hear what the future holds for Deep and this whole field.
Well, get ready to be amazed. Because Deep's vision for the future is truly remarkable. They see underwater habitats becoming essential tools not just for scientific research, but for a wide range of applications.
So we're talking about more than just those research stations we discussed. What other uses do they envision?
They're exploring all sorts of possibilities. For example, they believe underwater habitats could play a key role in aquaculture, the farming of fish and other seafood. Imagine underwater farms where fish are raised in a controlled environment. minimizing the impact on wild populations,
Right.
and reducing the need for long-distance transportation.
Yeah, that would be a game changer for the seafood industry.
Right.
And it aligns perfectly with Deep's focus on sustainability.
Exactly.
What other applications are they considering?
They're also looking into the potential for underwater construction and maintenance. Think of underwater habitats as bases for teams working on offshore wind farms,
Right.
oil rigs,
Yeah.
or even underwater pipelines.
Okay.
Having a permanent presence underwater
Right.
could make those operations much safer and more efficient.
I can see how that would be a huge advantage.
Yeah.
But those all seem like pretty industrial uses. What about something a little more, well, fun?
That's where things get really interesting.
Okay.
Deep is actually exploring the possibility
Yeah.
of creating underwater habitats specifically for tourism and recreation.
What?
Imagine underwater hotels where you could wake up to the view of a coral reef outside your window.
Oh, wow.
Or spend your days diving and exploring the ocean depths right from your doorstep.
Wow, that sounds incredible. Underwater hotels.
Yeah.
It seems like something straight out of a science fiction movie.
Right.
But I guess with Deep, the line between science fiction and reality is starting to blur.
Yeah.
But wouldn't that kind of tourism have a negative impact on the environment?
That's a valid concern.
Yeah.
And it's something Deep is acutely aware of.
Okay.
They're committed to developing eco-friendly tourism practices
Okay.
and ensuring that any underwater hotels they create
Right.
have minimal impact on the surrounding ecosystems.
Okay.
They're looking at things like using renewable energy sources, minimizing waste,
Right.
and even incorporating artificial reefs into their designs to promote marine life.
It sounds like they're really thinking through all the angles.
Yeah.
It's reassuring to hear that they're prioritizing sustainability alongside innovation.
Right.
But let's be realistic for a moment.
Okay.
Even with all the technology and precautions, living underwater must come with some inherent risks.
Absolutely. It's still an extreme environment, and there's always the potential for unexpected challenges.
Right, like what?
Equipment malfunctions,
Okay.
power outages,
Right.
medical emergencies. Those are all possibilities they have to prepare for.
So how are they addressing those risks? What kind of safety measures are in place?
Safety is Deep's top priority.
Okay.
All their habitats are designed with multiple redundancies, backup systems, and emergency protocols.
Okay.
They rigorously test every component and train their crews to handle a wide range of potential scenarios.
Wow.
Plus, they're constantly monitoring conditions inside and outside the habitat
Okay.
to detect any potential problems before they become serious.
It sounds like they're taking safety very seriously,
Yeah.
which is reassuring.
Yeah.
But what about the psychological challenges of living underwater? We talked about the potential for isolation and confinement.
Right.
How are they addressing those issues?
They're applying those same human-centric design principles we discussed earlier.
Right.
They're creating spacious living areas with natural light,
Okay.
incorporating virtual reality experiences to simulate the outside world,
Right.
and providing ample opportunities for recreation and social interaction.
Okay.
They're even experimenting with using artificial intelligence
Oh, wow.
to create personalized virtual companions
Really?
that can provide emotional support and companionship to crew members.
Wow. AI companions, that's getting really futuristic.
Yeah, it is.
But it makes sense.
Uh-huh.
It's all about recognizing that human beings are social creatures with complex needs,
Yeah,
even when they're living in an underwater habitat.
exactly. Deep understands that the success of these missions depends not just on the technology,
Right.
but on the well-being of the people involved.
It's been fascinating to explore this world and see how far we've come since those early pioneers first ventured beneath the waves.
Yeah.
From those small rudimentary habitats to the sophisticated structures Deep is building today. It's clear that underwater living is no longer a dream, but a rapidly evolving reality.
Right?
So where do you think this is all headed? What's your prediction for the future of underwater habitats?
Well, I think we're just at the beginning of an incredible journey.
Yeah.
As technology continues to advance and we gain a deeper understanding of the ocean environment,
Right.
I believe we'll see underwater habitats become increasingly common and integrated into our lives.
Wow.
They could be used for research, for tourism, for industry, and perhaps even for permanent human settlements.
It's mind-boggling to think about the possibilities. Imagine a future where underwater cities exist alongside our terrestrial ones.
Yeah.
Where humans live and work in harmony with the ocean.
It sounds like science fiction, but who knows? Maybe one day our descendants will look back at these early underwater habitats with the same sense of wonder and awe that we feel when we look at the first rockets that took us into space.
It's a beautiful thought. And on that note, we've come to the end of our deep dive into the world of underwater habitats.
Okay.
It's been an incredible journey, full of fascinating insights and inspiring possibilities.
I hope our listeners have enjoyed the exploration as much as we have.
If you're eager to learn more about DEEP and their work, be sure to visit their website.
Right.
They have a wealth of information about their projects, their technology, and their vision for the future.
And remember, the ocean is a vast and mysterious realm full of secrets waiting to be discovered. Who knows what wonders await us in the depths?
That's a great reminder. Thanks for joining us on this underwater adventure.
Until next time, keep exploring.